Today we're going to learn about proving congruence in triangles and proving congruence in right triangles. I will be moving fairly quickly through these. Feel free to pause it so that you can get all the information written down before I go to the next slide. Side congruence. If three sides in one triangle are congruent to three sides in another triangle, then the triangles are congruent to each other. Meaning, if we have three sides here, congruent to three sides here, then the triangles must be congruent. There is no other way for them to be drawn, so they must be congruent to each other. Our next congruency, side, angle, side. If two sides and an included angle in one triangle are congruent to two sides and an included angle in another triangle, then the triangles are congruent to each other. We have side. The included angle means between the two sides, side. Side, included angle, side, congruent to side, included angle, side. Side, angle, side congruency. Next is angle, side, angle. Very similar, we have if two angles and an included side in one triangle are congruent to two angles and an included side in another triangle, then the triangles are congruent to each other. We have an angle, included side, angle. Checking on the other one, we have angle, included side, and angle. The triangles are congruent to each other. Next is the angle, angle, side. If two angles and a side not between them in one triangle are congruent to two angles and a side not between them in another triangle, then the triangles are congruent to each other. Here we don't want the side between the angles. We go angle, angle, side. Checking the other one, we have angle, angle, side. We have our angle, angle, side, so we therefore have two congruent triangles. Next is the hypotenuse-leg. This can only be used with right triangles. You cannot use this with any other types of triangles, only with right triangles. In a right triangle, if one leg and the hypotenuse are congruent to one leg and the hypotenuse of another triangle, then the triangles are congruent. We look, we have our right triangles. Now we check. We have the hypotenuse between the two triangles congruent, and we have a leg. Therefore, we can say we have hypotenuse-leg congruency. Let's try and use this. Question, are the triangles congruent? If yes, which congruence theorem proves they are congruent? As I look at these two triangles, I have an angle congruent between them, I have a side, and then I have another angle. The side would be called included because it is between the two angles. Therefore, I do have an angle side angle congruency. So I do have one of our 5 congruencies, and this time I will use angle side angle. The next one, we check, we have a side in the first triangle with the single tick mark congruent to the side with the single tick mark in the second triangle. Then we have an angle, and then we have another side. The angle is between the two sides. We do have angle congruency or triangle congruency here, but this time it is going to be called side angle side because the triangle is included between the two sides. Next, we have a congruency with 2 tick marks, another one with 2 tick marks. Then as we go around the triangle, we have a single tick mark here and a single tick mark here. Although the orientation is different, we do still have the side with 2 tick marks right next to the side with 1 tick mark. We just travel around this triangle going counterclockwise, and this one, counterclockwise, and this one going clockwise. As long as they're in the same order, the direction we find that order is not as important. This one is still a congruency, matching, because we have the side, and then we have a side, and then we have an angle. We have a side, and then we have a side, and then we have an angle. So it looks like we have a triangle congruency, which would be side, side, angle. However, side-side angle is not one of the accepted triangle congruencies. It does not work, therefore we say that it is not, these two triangles are not congruent. To better demonstrate why this is not true, I have a sketchpad file here I've created. The parts are color-coded. The blue segment is the same length as the blue segment on the second triangle. The red segment on the top triangle is the same as the red segment on the bottom triangle, and the green angles are congruent between them. You'll notice as I move this point, the red segment changes equally in both of the figures. The blue segment is not changing length at all, and the angle is changing equally between them. Now notice what happens as soon as I get past, I'm right here at about 90 degrees. Notice what happens when I go more than 90 degrees. The blue segments are still the same size, the angles are still the same size, and the red segments are actually still the same size. If we try and use side-side angle congruency here, it does not work. Even though the red side is congruent to the red, the blue is congruent to the blue, and the green angle is congruent to the green angle, we can obviously see from our picture that side angle side does not work. Therefore, back in this question here, we shouldn't write side-side angle. We either erase it or cross it out and write no. These two triangles are not congruent. You could also write not and then put in the congruency symbol. Not congruent. Here's one. Are these triangles congruent? I will tell you right now they are congruent. Now let's see if we can figure out why. As we look at the figure, we only have one side congruent to one side. But if you remember back from chapter 3, these arrows on the lines mean we have parallel lines. So we have parallel lines cut by this black line right here, which we would call the transversal. I put a green dot on it so you could see it better. That line is called the transversal. Therefore, we could call this angle here and this angle here alternate interior, which means they are congruent. We're a little bit closer. Now we have one side and one angle. Lastly, if you think of these triangles as being pulled apart, these two triangles have a side that they share in common. That is this side right here. That side is part of both triangles. That is called the reflexive property. When one piece is shared amongst two different figures, it is reflexively congruent to itself. Everything is always congruent to itself. Now we do see the congruency we have, hopefully, and that is side, angle, side. We have one more thing in today's lesson, and then you're done. That is, we're going to do a proof. We're given a picture, RQST or RQTS, and we're given some information. We're told that RQ is parallel to TS. That means that we can put the arrow on this one and the arrow on this one. And we're also told that side RQ is congruent to side TS. That means that this side here, RQ, is congruent to this side here, TS. We have the beginnings of our proof. If you remember from our last lesson, we always start with our shun. Now we need to figure out more pieces so that we can prove these two triangles congruent. There's always a reason that we're given information, so that all that information must be used for something. The congruency obviously gives us one of our three parts we need to prove these triangles congruent, But we need to go back to what we learned last chapter about parallel lines to use this parallel line part. We have two parallel lines. We have a transversal that cuts across them. We now could say that we have some congruent angles. Now that we have the two angles congruent to each other, we need one more piece. The one more piece, if you can remember from the last slide, or from the last thing we were talking about, is we can say that RT is congruent to itself. The reason that we can say something is congruent to itself is because of the reflexive property. Now if we look at our picture, we have side, angle, side congruency. And if you remember back from when I've talked about proofs in the past, what we're trying to prove, or the proof statement, this proof statement will always be the last step in every proof. Since we're trying to prove QRT is congruent to STR, that is the last thing that we're going to state. QRT is congruent to STR. The reason we know that is because of side, angle, side. Make sure you've taken good and thorough notes and bring your questions to class if you have any.